Okay, so Nicholas has got that one of the differences is that sine crosses at the origin and cosine does not. That's true. Cosine has a y-intercept at +1. David's got that they're the same, they have the same domain and range. Their domain is all real numbers and their range is -1 to 1. That's true. Okay, Valerie's got that they're alike and that they have 5 key points that define their function. And that's going to be true for all of our trig functions, which is super nice. That MAPI format that we're going to learn today for graphing them will work for all 5, will work for all 6 trig functions rather. So that's awesome. So that's important that you remember they do. They have those 5 key points. She said they're different in that the first key point for cosine starts at 1, whereas the key point for sine starts at 0. And that's exactly right. 0 is the midline there. So it's sine starts at the midline. They both are sinusoidal waves, Shay said, and that's true. They're that wave shape. They're the sinusoidal waves. And good. I love it. Sarah even used that midline terminology. You can tell she's been watching her video notes. She's ready. Omar said the hills and ravines are different. That's true. There's a phase shift between the 2 graphs. So while they're the same shape, there's a phase shift, which makes those maximums and minimums fall at different places. Okay. Excellent, excellent. And then a lot of you shared those same ideas. So very nice. Okay, so good insight, good insight. Okay, so like I said, in my remind, you guys need to be watching those video notes. Today we're moving with the expectation that you've already watched the video notes. We'll quickly go over them, and I'll answer any questions you have, but you really have to be watching those video notes to kind of prime yourself and lay the foundation for what we're doing in class. Okay, so we are talking about sine and cosine that are both sinusoidal curves. In our Desmos activity, we explored how they are the x and y values pulled as we move around the unit circle for different angles, just plotted in a rectangular plot, okay? So just like if we start at the angle 0 degrees, that at 0 degrees our sine is 0, at 0 degrees our cosine is +1, and that's where we get the different starting points, sine at the midline, cosine at the maximum when we start at 0 degrees at the y-axis, okay? Hopefully all these visuals help you make those connections. A lot of vocabulary this unit, and as a refresher of these vocabs that you heard in the notes, periodic functions repeat exactly in regular intervals. The midline is how far up or down we shift the function. It's the new middle of the graph, okay? It reveals our vertical translation. The amplitude is the distance from the midline to the maximum or from the midline to the minimum. The amplitude is always positive, okay? So when we see a negative out front, that's not part of the amplitude. The amplitude's always positive. That negative out front will just be one of our transformation rules. Just like always, a negative out front is a reflection across the x-axis, okay? Phase shift is how far to the left or right we shift the function. That's also known as the horizontal translation. The phase shift is going to be our C value inside with the X, just like our I-hot over rules. Inside's a horizontal shift in the opposite direction. So that's going to give us our phase shift or horizontal shift. The period is the length of one complete cycle. That's how long it takes to complete a cycle. Okay, and the frequency is how many cycles are completed per unit of time. So, or it not necessarily time per unit of measurement. Often it's time, but for us it won't be. It'll be per angle measure. The frequency is just the reciprocal of the period. Okay, the frequency is just the reciprocal of the period. So like if your period is 2 pi over 3, let me write this down so that I'm not just speaking, but I can show you. So if your period is 2 pi over 3, then your frequency would be 3 over 2 pi, meaning that you complete 3 cycles every 2 pi units. Okay, so if it takes 2/3 of a pi unit to complete a cycle, then every 3, you'll complete 3 cycles every 2 pi units. Okay, so it's just the reciprocal of the period. Questions on any of that vocab before we start moving forward? Okay, and I can always come back, so if you don't get a time to type your question, feel free to keep typing, and when I see it pop up, I'm happy to hop back and answer questions. You can unmute and get me. Okay. All right. So we did all of our functions unit. We did a functions unit earlier this year. You've done a lot of functions in Algebra 2, certainly in Algebra 1. You started with your quadratic functions. And so the transformation rules are the same for all of our functions. As far as inside is a horizontal shift in the opposite direction, that affects the domain. So you'll see that there is our C value. Okay. And notice it says minus C because it's going to be the opposite of what it looks like. It's going to be the opposite of what it looks like. So in math, when we read a negative, we read that as opposite. Okay. Outside, this is going to be our D values at the end. Outside is a vertical shift in that exact direction. It affects the range. Now here on screen, I have the little format for either a sine or a cosine function. It's the same format. All we changed here was whether it was sine or cosine. Next time or 2 times from now when we meet, we'll change it out with secant, cosecant, tangent, cotangent. Okay, for all of our trig values, they're going to follow the same format. So let's be a little more explicit about that format as a refresher. Okay, remember A stands for amplitude. Okay, so we get that alliteration to help us remember that amplitude is the A value out front. Okay, it's the coefficient on the trig function. Remember, the amplitude's always positive. Some people write it as the absolute value of A so that you know if you see a negative with it, you're not associating the negative with the amplitude, but rather the negative is its own transformation rule, a reflection across the x-axis. Okay. Our B value helps us find our period. It's not our period, but it helps us find the period. Remember, period is going to be the period of the parent function. Period of the parent function. Period of the parent function divided by B. Okay, and if you remember from watching the circle go around and graph the sine and cosine function, it took a full rotation of the circle or 2 pi radians to complete the cycle. So when we do periods for our sine and cosine function, the period of the parent function is going to be 2 pi. But I say period of the parent function because when we get to tangent and cotangent, we'll see their parent functions have a period of pi. They actually finish faster. And so it's going to be the period of the parent function divided by, and that's a B, not a 6. That kind of looks like my little screen's moving as I'm trying to write on it, so I apologize for the messy handwriting. Okay. Then the C value, we said the C value is our phase shift. That's going to give us our starting point. That lets us know how far over the cycle is shifted. So that's going to give us our new starting point. That's our phase shift or horizontal translation. Horizontal translation. Okay, and that'll be our new starting point. And the D value here at the end, that's our vertical shift, which reveals our new midline. Okay, so that's going to give us our midline. That's how far up or down we shift it. Okay, so that's going to be our vertical translation. It's going to be the new middle of our graph. Okay, so when you start, there's 0 vertical shift with the parent function, and so it's centered at 0 on the x-axis at a y value of 0 on the x-axis. Okay, but we're going to shift it vertically however much it tells us to, and that's going to give us that. Now, when I created this presentation, I forgot that once we're in the pear deck, it won't let me move that box away. But what this box says in it, and it's important, is that we always want a positive B value. We're going to talk about this next class. Today, they're all going to be positive. We want a positive B value. But for me, I hate having something added at the end, like new information. I like to know everything from the beginning. So just know that we always want a positive B value. If we have a negative B value in there, we're going to use our even and odd properties to handle that, and we'll talk about that next class. Okay, but just know that we always want a positive B value. Okay, questions for me on the different transformations that we can do to our trig functions? We're going to practice graphing them here and just on the next screen, but just any questions for me before we jump to it? All right, let's give it a try. Let's go, let's go. This is the process, the steps we're going to take to graph a sinusoidal function. Now, this MAPI acronym is meant to walk you through the steps, and it's super helpful. And he said in the video notes, you can call it VAPI if you want for vertical shift instead of midline. I like it as the midline. I actually draw in the midline. So M stands for midline. So we're going to graph our midline. A stands for amplitude. From that midline, we'll go up the amplitude and mark our maximum. We'll go down the amplitude and mark our minimum, okay? The first P stands for phase shift, and we're going to mark the phase shift. The horizontal shift is our new starting point of our cycle that we're going to graph. The second P stands for period, which is always period of the parent function divided by B. Remember, this won't actually show up on your graph, but we'll use it to check that our graph is correct once we've finished graphing a cycle, okay? The I stands for interval. To find the interval, we're going to grab that period that we just found in the step above and divide it into 4 equal parts. We'll mark off those 4 equal points on the x-axis, and we'll count by the interval when we're labeling them. So starting at our phase shift, we'll count by the interval to correctly label those 4 additional key points, okay? Now, once we know their x values and their y values, we're ready to follow the pattern of the parent functions to plot our points. So for us, this first graph is a y equals sine x graph. You see it starts at its midline, maximum, midline, minimum, midline. So that's going to be the pattern that we follow. The second graph on the right shows a cosine function, y equals positive cosine function. The pattern you should recognize there is that positive cosine starts up at the maximum. It goes maximum, midline, minimum, midline, maximum. Okay, so if you can pick the correct starting point, because these are waves, they're going to continue just moving in the wave. Like with cosine, when we're up at the maximum, the only place we can go is down to the midline and then to the minimum and then back to the midline and then back to the maximum. When you're at the maximum, you can't jump to the minimum without passing through the midline because it's a continuous function. It's a continuous wave. So if you know where your starting point is, it's pretty easy to finish graphing these correctly. All right, questions for me on that process that we're going to take. We're going to do it together, so it's kind of just nice to have it written out, and these are in our blank and completed notes in the Schoology folder, so you can come back and look at the steps to help you graph. Okay. So when we talk about those key points, the difference between positive and negative is important. So we said that this is going to be our positive sine function. I know it's a positive sine function because while it starts at the midline, it opens up. It goes up. Positive opens up. If it's a negative sine function, like we have graphed here in the second one, it still starts at the midline because sine always starts at the midline, but then that negative out front means it's opening down or headed down when it opens, okay? And so that's very intuitive and pretty easy to remember. If it's positive, go up. If it's negative, go down, okay? And that intuition follows when we're looking at cosine functions. If we look at this first one as a positive cosine function, so because it's positive, it starts up at the maximum, then goes midline, minimum, midline, maximum. Remember, it'll always end where it started. That's how you know you've completed the full cycle, okay? But in the second graph, it's y equals negative cosine x, and that negative reflects it across the x-axis. So instead of starting at the maximum like positive cosine, because it's a negative cosine, it's going to start at the minimum, but then it will still follow that wave, minimum, midline, maximum, midline, minimum. Questions for me on what the negative does to those functions? Okay. All right, we're ready. Let's do it. Let's do it. We have a function here, and this one is actually in graphing form. If you look at it, it perfectly matches that format that we gave you of y equals a sine b x minus c plus d, okay? So it's in graphing form. It perfectly matches that format. So we can see our A, B, C, and D values. Now that's important to notice because our functions aren't always given to us in graphing form. And so sometimes we'll want to manipulate them algebraically to get them in graphing form. You'll notice on Delta Math and on My Math Lab, they're often not in graphing form, but then they often aren't asking you to fully graph it, so you don't need it completely in graphing form, and I'll point that out when we see some examples like that in our notes later today, okay? But this one is in graphing form, which is nice because we're actually graphing this one. I'm going to write my MAPPY acronym out to the side to help me get started. MAPPI, and it'll walk us through it. Okay, first question is midline, so can you help me with that? Where is my midline? Where is my midline, Taryn? You can have your notes handy there to remind you. Midline is our D value. Do you see it?
Hello, is this working?
I can hear you now.
Oh, sorry. Midline is in -4. I was trying to say that.
No problem. I saw your green dots were going, but I didn't. But I didn't hear you, so I'm glad you got that figured out. So thank you. Okay, and he's right. And notice that he said -4, and that's exactly right. Sorry, I accidentally turned off my other device when I was trying to get the volume up. Okay, so our midline is -4. Okay. And Taryn, while you're right there, what is our amplitude this time? What's our amplitude?
The amplitude is...
A stands for amplitude. So
it's 4.
So it's actually, so A stands for amplitude, so it's the coefficient out front. So that's going to be 5 for us this time. Okay, so it's going to be 5. Now, the reason I look at the midline and the amplitude before I start drawing my graph is because I want to decide where to put the x-axis. I know I'm going to want the y-axis over here on the left side because we're getting started. And sorry, that's such a wonky y-axis. We'll try to make it a little straighter. But I know that the middle of my graph is going to be down at -4. So I'm going to put my x-axis higher so that I can have the center of my graph or midline at -4. It just keeps me from having my graph scrunched below. So the midline's at -4, so I'm going to draw it in and sketch it. The reason I asked for the amplitude first is because the amplitude tells me whether or not I'm going to need to see the positive side of that x-axis. Because my amplitude's 5, I am going to go up above it. So I left room. So if I go 5 units up from my midline, that gets me to a maximum at +1. Now we want to go 5 units down from my midline to a minimum at -9. And when you're graphing these by hand, I really only want to see those 3 key values on the y-axis. I want to see where your midline is, where your maximum and where your minimum are going to be. Okay. Questions about that? All right. So that's what we do with the midline and the amplitude. So our first P stands for phase shift. Can you spot the phase shift for me? Valerie, where's my phase shift? It's our C value. 2? No. So the 2 is the B value, and the B value will help us find our period, which is the second P. The first P is phase shift. That's going to give us our starting point, and it's the C value. So can you pull out the C value in that equation?
Would it just be pi, or would there be 0?
It's just the pi. It's just the pi. So
okay.
In the generic graphing form, it says x minus c, because remember, inside is always a horizontal shift in the opposite direction. So it looks like -pi, but it's actually going to be +pi. So our phase shift is pi units. So on the x-axis, I want you to come in the positive direction and mark pi units. And that's going to be where our first key point goes. That's the x value where our first key point will go. Okay, now we're ready to find the period. And for the period, it's the period of the parent function divided by b. And so we said sine and cosine's parent functions have a period of 2 pi. And Valerie, what did we say the b value was for this equation?
2.
Exactly. It's that coefficient on the x. 2 over 2 cancels, and so that gives us a period of pi units. Now, this isn't going to show up in our graph yet, but we'll use it to check our graph in just a minute. Okay. Now, the last letter in MAPPY is I, which stands for interval. To find the interval that we're going to count by, we're going to grab the period that we just found and bring it down here and divide it by 4. So we're going to do pi divided by 4. That means our interval that we count by is going to be pi over 4. So go ahead and move out from your starting point, your phase shift, and mark 4 equally spaced points. Okay, 4 equally spaced points. And to label them, we're going to count by our interval. So we're starting at pi, and we want to add pi over 4. Well, since we're adding a fraction, we need a common denominator to add fractions. So let's do a little scratch work at the top. Right now we have pi, and we want to know what it looks like over a denominator of 4. Okay, so right now it's over a denominator of 1. So what do we have to multiply the denominator by to get it to look like 4? We multiply it by 4. And what we do to the denominator, we have to do to the numerator. So that's going to give me 4 pi over 4 is what a whole pi looks like over that common denominator. Are you guys okay with that? Can you see that 4 pi over 4 would simplify to 1 whole pi? Okay, Shay says yes. Thanks for the response. I appreciate it. Okay, so we're starting at a whole pi, which is 4 pi over 4. When I add pi over 4, I get 5 pi over 4. When I add pi over 4, I get 6 pi over 4. When I add pi over 4, I get 7 pi over 4. When I add pi over 4, I get 8 pi over 4. Okay, and that's what I mean by we're counting by our interval of pi over 4. We're adding pi over 4 every time. Now, I was just going to say, I knew that Shay asked it, and I knew a lot of your algebra eyes were going, wait. That is not right. Nicholas has the same reaction, and I love it. I love it that your little math hearts were like, I can't leave it like that. We're not going to leave it like that. We're absolutely going to simplify those fractions, but I wanted to show it like that the first time so that you can see that that's all we're doing, and then we'll simplify them. So hopefully you've got an eraser handy and can come back. 5 pi over 4 doesn't simplify, but 6 pi over 4 does. So we're going to simplify that one down. That'll simplify to 3 pi over 2. 7 pi over 4 doesn't simplify, but 8 pi over 4 does. What does 8 pi over 4 simplify to? It simplifies to 2 whole pi. Okay. Now this is where we can use our period to check that we counted and have our interval right. The period is how long it takes to complete one full cycle. So it should take us pi units to complete a full cycle. Since our cycle started at pi and it's ending at 2 pi, did it take pi units to get through one full cycle? It sure did. So that lets us know, okay, yes, I counted my interval right. I have it correct. It is going to be a period of pi units. Okay. Let me see. I've got a question. Why does it go from pi to 5 pi over 4? Okay, so look at our little scratch work above here. What is a whole pi with a common denominator of 4? Okay, a whole pi is 4 pi over 4. Can you see that that 4 over 4 would cancel and simplify down to a whole pi? A whole pi is 4/4. Okay, like if you have a fourth of a cup, it takes 4/4 to make a whole cup. Okay, so a whole pi is 4/4. And no apologies, Noah. No, like that, like you're never the only one that doesn't see the connection or has a question and is wondering. So I appreciate you asking. I'm always grateful for the questions, okay? So never apologize for asking a question. Okay, so we have our 5 key X values and we have our 3 key Y values. So we are ready to graph. I'm gonna come erase where I showed, sorry, not that far. I was trying to get back to erase my period that's on there. Okay, because I don't want that interfering, but I was just showing how we can check that it does take our period to get through the 5 key points. Okay, and now we just follow the pattern of the parent function, meaning I'm going to come to my phase shift, which is my starting point, and where does a positive sine function, so come look at your parent function, this is a positive sine function, where does a positive sine function start? Can you tell me, Yassine, where does a positive sine function start? Do you remember? Sine functions always start where? Your choices are minimum, midline, or maximum. So Yassine, where does a sine function start?
The mid, right?
Yep, it always starts at the midline. So I'm going to come to pi, which is my first X value or starting point, and I'm going to plot a point at the midline. Okay, now it's a positive sign. So you've seen which way is it going? Is it going up to the maximum or down to the minimum?
I think it's going up, right?
Yes, and that's what I said. It's kind of intuitive. Positive goes up. So it's a positive sine function, so it's going to go up to its maximum. Once we're at the maximum, there's only one place you can go, and that's back to the what?
Minimum?
So it can't jump straight to the minimum. It's got to pass through the midline before it gets to the minimum. So our next place is going to be back to the midline, and then it will drop down to the minimum. And once we're at the minimum, where do we have to go, Yassine?
Then we go to the midline.
Exactly, because we can't, it's the minimum, we can't go any lower, and we can't jump back up to the maximum without passing through the midline first, okay? So can you guys see those 5 key points? Midline, maximum, midline, minimum, midline, and they fall at those X values. Okay, once we have the 5 key points plotted, we're gonna connect them with a smooth curve. Now, I see a couple of you guys doing something that I saw Mr. B do in his video notes. Do not add arrows at the end of this graph, please. And I need to go talk to him about this. But I saw he did do it in the notes. Okay, so I wanted to clarify and talk about it. The reason we don't put an arrow at the end of our graphs here is because an arrow means that it continues forever and ever in that direction, okay? We all understand the idea that this is only one cycle and that it is going to continue following the cycle. But I don't want you pointing up and down because that would indicate that it just goes up or just goes down forever in that direction. And I know he did that. And like I said, I'll talk to him about that and we'll get that corrected, okay? So that's why the instructions usually say graph 1 cycle of, graph 2 cycles of. And so here we're just starting with 1 cycle of that. That's a positive sine function. Questions for me about that? Okay, if they asked us to graph a second cycle, could we? We sure could, and we'll show you that on the next example. So let's go ahead and look at our next example and practice this process again, okay? Okay, this time we're graphing a cosine function, and I want you to notice a couple things before we get started. The first thing is that 1 is out front, okay? Now, our graph does not show a constant, our graphing form does not show a constant out front, okay? So this is not in graphing form. If you understand what that 1 is, you don't necessarily have to rewrite it in graphing form, but because when we're new at this, I especially just feel more comfortable when it looks exactly like the template for us. And so I'm going to rewrite that with that 1 at the end. So it's still a -4 cosine. And if you want to do your bracket and separate your pi from your x, you can, because the b value is just the coefficient on the x. And then that +1 that's out front now can get moved to the back. And now we're in graphing form. Now it looks just like it did in the template, okay? Now, addition is commutative, meaning you can change the order of your terms and it doesn't change your answer. As long as you keep your negative with the 4 cosine where it belongs, it doesn't change our answer whether that +1 is added in the beginning or added at the end, okay? So addition is commutative. You can change the order. It doesn't change your answer, but sometimes we're more comfortable with it at the end because it looks like the right format. All right, let's get started. I'm going to write out my little mappy on the side to kind of walk me through this process. The first thing I need is my midline. So let me check. Zachary, I gotta make sure you're here. Yes, Zachary's here. Zachary, where's my midline in this graph? Where's my midline gonna be? Midline is our D value. Okay, it's our constant that's outside of the equation. That's what creates our vertical shift. Nicholas there with the assist, but Zachary was coming. He knew it. He knew it. Thank you, Zachary. And thank you, all of you guys, for being willing to help. You're right. That constant at the end is our midline. That's our vertical shift, and that's going to give us our starting point. So our graph is going to be centered at +1. Okay, what's our amplitude, Zach? What's the amplitude? A is for amplitude, so it's that first coefficient on the trig function. What's our amplitude? And Zach got it right. It's +4. And notice that he said +4 and not negative. That negative is important. In fact, I'm going to do a little flower cloud around it just so I don't forget about it. That negative is important, but it is not part of our amplitude. So our graph, when we're deciding where to draw, we're going to draw our y-axis. And when we're deciding where to put our x-axis, it's going to be centered at the midline, so +1. So I'm just going to put my x-axis just a little bit below center, so that when I mark my midline at +1, it's kind of in the center of my page, just to keep my graph centered. You don't have to do that, but I like it. It just kind of gives me space so my graphs don't end up scrunched. Okay, now from the midline, we're going to go up the amplitude to get to our maximum. So 1 plus 4 will give us a maximum of 5. And we're going to go down the amplitude 4 units to get to our minimum, which will be 1 minus 4 is -3. So our minimum will be -3. Okay, so that's how we use the midline and amplitude to graph those. Okay. Questions for me on midline amplitude? Are we doing well so far? Okay. First P stands for phase shift, So Sarah, where's my phase shift? And that's kind of a trick question. Maybe I should clarify before I ask that question.
Is
What-
it just 0?
Excellent. She was ready for it. It's the C value. So when we think about our format, not in a thing. Okay, so that generic format is y equals a cosine b x minus c plus d. Okay, so when there's nothing subtracted from the x, then it is 0, which means we have 0 phase shift. That's fine. It still tells us our starting point. Our starting point is at 0. So on the x-axis, my first of the 5 critical values is 0. So I'm going to go ahead and mark it because I want to still remember that that's going to be my starting point. Okay. The second P stands for period. Period is always the period of the parent function, which for cosine and sine is 2 pi, divided by our B value. Sarah, what is our B value?
Pi.
Yes, and it looks a little funny, but pi is just a number. We know it's about 3.14159, okay? And so you might be kind of nervous when you see pi there as your number, but it actually makes our period really nice because when we have pi over pi, the pi's cancel. So that simplifies down to just a whole number for our period, which is kind of nice. Okay, now remember, our period doesn't get graphed right now, but we're going to grab our period and bring it down here to find our interval. To find our interval, we're going to use the period that we just found and divide it by 4. 2 over 4 simplifies to a half. So the interval we're counting by is going to be a half. Okay, so come to your x-axis, and from your phase shift or starting point, I want you to space out 4 equally spaced points. Okay, and we're going to label them by counting from our phase shift, from our starting point, by our interval of a half. So 0 plus a half is a half, plus a half is a whole, plus a half is 3 halves, plus another half is 4 halves, which is 2 whole. Okay, now we did simplify there. Most of you can probably do that in your head. When it was 1 1/2, we left it as the improper fraction 3 halves. Okay, when it was 4 halves, we simplified it to 2 wholes. Questions on counting by your interval there? Okay, so let's go ahead and graph our graph. Now make sure you go back to your original equation and look, this is a negative cosine function. And this is where I circled that negative so that I wouldn't forget about it. It's a negative cosine function. So tell me, Jada, where does a negative cosine function start? Where does a negative cosine function start? So sine starts at midline, but cosine starts where? And if it's negative, it starts where?
Is it the 0 axis? Like
the midline? It's not at the midline. So it's going to be, so if we go back, well, let me see. I don't want to jump around. So it actually starts at the minimum. When it's a negative cosine, it's going to start at the minimum. So as 0, we're going to go down to -3 and we're going to plot our first point. Okay. Once we're at the minimum, we've only got one way to go. Where's our next key point going to be, Jada? And your choices are minimum, midline, or maximum. So we're down at the midline. We're down at the minimum, so we can't go any lower. So where do we have to go?
the midline?
Yes, because we can't jump up to the maximum without going through the midline. That's exactly right. Okay. So then where will we go next, Jada?
The maximum.
Yes. And then back to the
Midline.
Yep. And we'll end up at the
Minimum.
which is where we started. And that should always happen. When you get through the full cycle, you should end where you started. So let's go ahead and connect that with a smooth curve. Remember, it does need to look like a wave and not a mountain. And what I mean by that is you need to have the little curve to the bottom pieces here. Okay, it's kind of hard with a cosine function to see the full curve, but can you see this time they want us to graph a second cycle? Once we get that second cycle there, that little curve that we have correctly drawn in there will really help it make it look like the wave that it needs to be. Okay, so if they want to see 2 cycles, what are we going to do? Well, we already know where our second cycle is going to start. It's going to start where the first one ended, okay? So that ending point of our first cycle is the starting point of our second cycle. So from there, we're going to come and we're going to mark 4 equally spaced points, and we're going to count by our interval. That last one doesn't look equally spaced. I'm going to try to get equally spaced. Okay, so we're going to count by our interval. So we're at 2, and we're counting by a half. I'll give you a second to draw it in. I know you didn't know I was going to make you squeeze in another one there. So, okay, so starting at 2, 2 is 4 halves. So one more will be 5 halves. And then it'll be 3, because 6 halves is 3. Then it'll be 7 halves. Plus a half is 8 halves, which simplifies to 4. Okay, so notice our period again. Our period was supposed to be 2 units long, and this next cycle starts at 2 and ends at 4, so that is 2 units long, so that is my period. Okay, so that's good. It just kind of confirms that, yeah, we're on track. We're making it the right size. Okay, so help me plot these points. Lennon, we're down here at our minimum, starting our second cycle. Where are we going from there? Where are we going from there, Lennon?
You go to the midline.
Excellent. Okay, it's the only place we can go if we're at the max or min. Then where are we headed, Lennon?
Back or to the maximum.
Yep. And then back to the
Midline.
And we'll end at the
minimum.
Perfect. Okay, connect it with a smooth curve. Wah! A little tricky, takes practice. Okay, and now you're starting to see that wave. Now you're starting to see that wave. It looks more like it. Sine already kind of looks like the wave when you graph it. Cosine looks a little weird when you only see one cycle. What if we wanted a negative cycle? Okay, then we would have just counted backwards. Okay, now the tricky thing about counting backwards, I like to label my 4 points going backwards, and I like to start at the leftmost one. Okay, because then you'll make sure you take your curve in the correct direction. So I still like to start at the leftmost function. So how many cycles you graph, Valerie, just depends on the instructions, okay? So sometimes they'll have us graph 1 cycle, sometimes they'll have us graph 2. It really just depends on the instructions. We know that it has a domain of all real numbers. We could keep going forever and ever if we wanted to, okay? The period is 2 units. The only reason we graphed 2 cycles this time is because they said at the bottom, can you graph a second cycle? So I just wanted to make sure you guys knew how to do that if you wanted to keep going. Okay, Emily asked, if this was not a negative y equals cosine graph, would your first point be the maximum? It absolutely would be. A positive cosine function starts at the maximum, but that negative means it reflected across the x-axis, so it started at the minimum. Yep, that's exactly right. Okay, good questions, ladies. Okay. All right. So that's a little bit of graphing by hand. We want to make sure you can graph by hand. If we were here in person, we would do primarily graphing by hand, this whole unit. But because our assessment devices are digital, a lot of times you're going to have to graph digitally. So let's look at what that's going to look like on Delta Math. So I have screenshots here on the next screen of the 2 graphing screens that you'll see when you're in Delta Math. Okay, so let's look at that for a second. Next class, I'll post a video of how to graph of Miss Boland showing how to graph in my math lab. But Delta Math is what you're doing right now, so we'll show you how to graph in Delta Math. And honestly, they really help you out. They do the majority of the hard work for the graphing, but we'll still talk you through it so that you're ready to do it. Okay, so here's a sample problem from Delta Math. It says on the axis below, make an appropriate scale and graph exactly 1 cycle of the trigonometric function y equals 6 sine 7x. Okay, so notice this is kind of a simpler equation. All it's got is an amplitude and a b value. That's fine, we can graph it. Okay, so it first asks us to label the axes. So the y-axis just wants to know what scale you want on the y-axis. And for all of them that I graphed, I found that a scale of 1 works fine. So I put a scale of 1 in there. If you want to make it something else, you can, but I usually just make it a scale of 1. Okay. Now, this is important, so I put it in red here. When it says x-axis label, it actually wants the period. It actually wants the period, okay? So let's go find our period here. The period is the period of the parent function, which for sine and cosine is 2 pi, divided by our b value. What's our b value here, Omar? What's our b value?
Would it be 7?
Yep, it's the coefficient on the x. So it's 2 pi over 7. So here, notice they have a little pi button right next to it. That's so that you can enter your period. And so it's a little small here, but this is where I would enter 2 pi over 7. So you'll do 2, hit the pi button, divided by 7, and it'll pop it up there, 2 pi over 7. Once you have the period entered for the x-axis and your regular scale, usually just 1 on the y-axis, you're going to click the done button. Okay, when you do that, your screen is going to change. It will now look like the screen on the right. Okay, it'll now look like this. They've dropped in your labels with a scale factor of 1 on the left, and they've dropped in a little blue dot on the right. And I know that's super small and you probably can't see it, but it has our period on it right there. It says 2 pi over 7 in a light blue dot. Okay, so here in the instructions, I remind you, after clicking done, place the blue dot, which now has your period label on it, where your cycle will end. Now, this is important to understand. All of the Delta Math graphing examples are kind of simplified, okay? You'll notice none of them have a phase shift, okay? They don't have a phase shift. None of them are shifted, so they're all with 0 phase shift. They're all starting at 0. So when you are going to drag that period to the ending point, that's because it's starting at 0, so the end of the cycle will be 1 period later. Since it started at 0, it'll end at the period. Okay, questions about that? All right, so I'm going to, because I can't drag it here in Pear Deck, I'm just going to draw a light blue dot where 2 pi over 7 will be. Now, it is up to you, the scale that you pick on your x-axis, but I recommend just using the first 4 lines as where your 4 key points are going to go. Like the first time I graphed this, I made them 3 units represented, 3 grid lines represented 1 key point, or my interval that I was counting by, and I marked it out. But then when I was actually plotting the little yellow dots for your 5 key points, it was harder to count. Was I on the next 3 grid lines later? Was I on 3 grid lines later? Was I on 3 grid lines later? So I recommend that you just use 1 grid line. It's going to make your graph kind of squish closer, but it's easier. Okay, so it says now you're going to plot your 5 yellow points. So I'm going to do my little mappy to help me. Okay, so M-A-P-P-I. And we're not going to need the whole thing to help us here because it's going to do most of the work for us. But the first question is, where's my midline? I don't have a vertical shift here, so it's at 0. So I know my graph is starting at 0. Now, you're not going to be able to draw on your Delta Math screen, okay? But just notice here that I know my midline is here at the x-axis. What's my amplitude? Nicholas, what's my amplitude going to be this time?
6.
So that means I'm going to go from 0, I'll go up 6 to my maximum, and I'll go down 6 to my minimum. And that's really all you're going to have to pay attention to here when you get started. Because I'm just going to use, it doesn't make you label your intervals. It doesn't make you label the x values for it. But the 5 points that you now have to plot, okay, it says plot 5 points for 1 cycle. You're going to plot those yellow dots, and they'll pop up as yellow by just clicking where you want them. Okay, so let's look at this equation. It's a positive sine function. So where should that first point be? Midline, maximum, or minimum? Where should that first point be? Anybody? Yep, Emily's got it. It should be at the midline. So you're going to click at the origin, and that's where our first point will be. Now it's a positive sign. So where are we headed next? Emily, I'll just let you help me with this one. Where are we headed next, Emily? It's
6.
Yes, because it's opening up. So you said 6. I usually just say maximum, okay, because it just reminds us the pattern that we're following, right? So midline, maximum. Where are we headed from the maximum, Emily?
Midline.
So at my next grid value, I plot on the midline, and then
down to the minimum.
Excellent. And last, our 5th key point will be at the
Back to the midline.
Exactly. We're going to end where we started. Now, all you have to do once you plot your 5th point, it's going to pop up a screen and it's going to say, are you sure those are your points or whatever? It's something like that. Are you sure that's what you want? And you're going to click submit. Okay. If you made a mistake, if you clicked in the wrong place, then you're going to click the reset button. You're going to click the reset button and it's going to clear all 5 yellow points and it's going to drag your period back off to the side over here. So you're going to have to drag it in again. So Valerie, to better answer your question, okay, so let me erase this for a second to show. Okay. So the first thing you're going to do is you're going to drag your period to where your cycle is going to end. And I didn't show drawing that on. So that should be 1, 2, 3, 4 grid lines from where we start at the y-axis. Then you're going to plot those 5 points, midline, maximum, midline, minimum, midline. Okay. And then you're going to click submit and it will draw in the graph to show you. So it'll connect them with the curve and then it'll show you the correct answer and let you compare it. Now, your correct answer and their correct answer might not look exactly the same, but it's still going to put a check mark on the screen to tell you that yours is correct. The reason they may not look the same is because of how you choose to space out your key points, Valerie. So this is what you were asking about. And that's where I said, I recommend for your sake that you just make the key points at 1 grid line over. Okay, if you do that, it will be easier. If you don't want to do that, if you want it spread out so that it looks a little prettier and uses more of the space, you can spread it 2 or 3 grid lines per key point, but you need to be consistent. They're supposed to be equally spaced. So if you want to use 2 grid lines every time, then from your phase shift or starting point at the y-axis, I would count out 2, 4, 6, 8 places to make my 4 more key points, and I would drag my blue dot to that 8th grid line as my stopping point. Okay, and so let me show you what it could look like there. So let me erase this and show you what it could look like there. So say you wanted to use 2 grid lines. I would count 2, 4, 6, 8, and I would drag my blue dot to here, saying that's where my cycle is going to end. Now when I plot my 5 key points, I'm at midline. I have to count 2 grid lines and plot the maximum, then 2 grid lines and back to the midline, then 2 grid lines and down to the minimum, then 2 grid lines and back to the midline. Okay, so there I'm using a different scale. It's a little more spread out, but that's why it had you drag your blue dot so that it knew where what you thought the period was, so that it could see if you were graphing it correctly. Now, when you click submit, it'll graph it like that, and it'll also count it correct. Okay, so you can count however many spaces over you want, but they do have to be equally spaced. Yes. So like when I started, I was doing 3 units every time, but it just makes it a little more stressful when you're counting. So if I wanted to do 3 units, I would count 3, 6, 9, 12, and that's where I would drag my blue dot to for the end of my cycle. Then when I graphed them, I would start midline, 3 units, 1, 2, 3 to the maximum, 3 grid lines to the midline, 3 grid lines to the minimum, and 3 grid lines back to the midline. And so when I click submit, it would connect it. And that's why I said the one you graphed and the one they graphed might look slightly different depending on the scale you picked. But I think it's a little stressful trying to count out those light little grid lines and try to make sure they're equally spaced. So my recommendation to you was to do it like we did the first time, where you just made 1 grid line count as your interval for your next key point. Okay, questions about that? Okay, so that's what it'll look like on Delta Math. They do a lot of the work for you. They don't even make you label your interval, but that's usually there's no complaints for it being easier. Okay, all right. Now, on your My Math Lab test, when we get to that, and sometimes in Delta Math when you're working on your practices, they won't ask for all of the graph. or even a portion of the graph, they'll ask for information about the graph. Okay, so we're going to try some separate questions here and see how we do just pulling out information from the equation to answer the question. Okay, so this says determine the minimum and maximum value for the following trigonometric function. Okay, so they just want the minimum and maximum. Well, think about your mappy process for how we get it. Okay, so if we're starting to try to figure out our key points, I need to know what my midline is first. So can you spot the midline there, Megan? Can you pull the midline out of that equation? Where's my midline?
-7.
Excellent. Okay, so it's going to be shifted down 7. I still do this little bit of sketch for myself. So I put the x-axis up high so that my midline's down below it, -7. I still think this is the easiest way to find the maximum and minimum. What's the amplitude, Megan?
5.
So from the midline, we'll go up 5 to -2, which will be our maximum, and down 5 to -12, which will be our minimum. So our minimum is -12, and our maximum is -2. Always feels a little funny to me to have the maximum be negative, but it is here. Our maximum is negative. Questions on finding the minimum and maximum there? Okay, now, will the amplitude cause a vertical stretch or compression? Will it be a shrink or a stretch? Okay, so think about your transformation rules. If this number that we're multiplying by is bigger than 1, is that going to be a vertical stretch or a vertical compression? What do you think? What do you think? Haley, will that be a vertical stretch or compression? Okay. And Amir was so fast, he was ready for us. You're right. When the amplitude is greater than 1, it'll be a stretch. It'll be a stretch, okay? So that's a vertical stretch by what factor? By a factor of 5. Remember, the amplitude is usually 1 on the parent function. So when we multiply it by 5, now we're going up 5 units instead of 1 unit. So it's a vertical stretch by a factor of 5, okay? Outside, away from the variable, is exactly what it looks like, okay? So it looks like 5, so the stretch is a factor of 5, okay? Questions about that? All right, let's look at another one.
Miss Weaver.
Since
there's no parentheses around the 2/3, would the 2/3 still be the b value?
It is. You can draw in your parentheses if you want there. And a lot of times that's what we like the parentheses for, is to emphasize and clarify what we're taking the sign of, okay?
Okay.
So if there aren't parentheses, it's just going to be the term closest to it. Remember, terms are separated by addition and subtraction signs. So this -7 separates that into a separate term. And
So
you can add the parentheses in there if you like. The b value is always the coefficient on that x. It is. So
okay.
that's still your b
So
value.
there's no c value, but there's the d value in that
Exactly.
situation.
On this one, there would be no phase shift or 0 phase shift. That's exactly right. Good job.
Thank you.
No, those are good questions. You're putting it all together. Very nice. Okay. All right, so here we have another one. It's that same kind of format that she was just asking about. If you want to add those parentheses to emphasize that to yourself, I like the extra parentheses there. They really help. Okay, so determine the minimum and maximum for this one. So can you kind of talk me through that? Can you try it on your own for us this time? Gavin, can you talk us through that? How are you going to figure out the maximum and minimum? What do you see? What are you thinking, Gavin?
Figure out what the midline is first.
Okay. And what is the midline?
3.
Okay, so if I put my x-axis a little lower, so my 3 can be in the middle. Okay. What's your amplitude, Gavin?
1/8.
Yes. So where's your maximum going to be?
Up 1/8.
Right. So I'm going to go ahead and call it 3 1/8 here. Okay. And where's your minimum going to be?
1/8.
1/8 down 1/8. So that would be 2 7/8. 2 7/8. Okay. So our minimum here is 2 7/8. which that's a mixed numeral. I thought it was easiest to write it there. So let's go ahead and convert it to an improper fraction. Remember, when you're converting mixed numerals to improper fractions, you multiply the whole number by the denominator, and then you add the numerator. Okay, so 8 times 2 is 16, plus 7 is 23. So that'll be 23 over 8. Okay, so the minimum is at 23 over 8. Our maximum, we said, was at 3 1/8. So again, if we multiply by the denominator and add the numerator, okay. 8 times 3 is 24, plus 1 is 25 over 8. Okay, so our minimum's at 23 over 8 and our maximum's at 25 over 8. You can see 24 over 8 would be right in the middle, and 24 divided by 8 does simplify to 3. Which is our midline. So we know we did okay on our numbers there. Okay, so there's our minimum and maximum. So good job with that, Gavin. Will this be a vertical stretch or compression, Gavin? If the coefficient that we're multiplying out front is 1/8, will that stretch our graph or compress our graph?
Compress.
It will be. It'll be a vertical compression. Now, on my math lab, they use the word shrink instead of compression. That's still kind of intuitive that compressing it is shrinking it or making it shorter, okay? But I wanted to put both words here so that you recognize it. That'll be a vertical compression by a factor of what, Gavin? How much will it shrink it?
1/8.
Yes, by a factor of 1/8. Okay, so when we're talking about vertical, okay, think about your IHOD over acronym for translations. Outside is exactly what it looks like, and it affects the vertical, okay? So outside, this 1/8 outside here is what's affecting the vertical stretch or compression, and it's exactly what it looks like. So if it looks like 1/8, it is 1/8. Now, horizontal will be different. Horizontal will be the opposite of what it looks like, and that's what's inside with the X, and we'll look at that on the next screen, okay? Questions for me on this before we go look at horizontal shrinks and stretches?
Do you prefer a mixed number or an improper fraction?
Improper fractions are what we use primarily in upper math. You'll hardly ever see a mixed numeral, okay?
Okay, thank you.
But for me, even for me, who's very comfortable with improper fractions, it was easier to add an eighth by just writing 3 1/8. You know, and it was easier to subtract an eighth by saying 2 7/8. That was more intuitive for me about where should that number be, okay?
Okay.
All right. Let's try another problem. Okay, so now they want us to find the period, and they want us to tell if that's going to be a horizontal stretch or compression. Okay, so now we're talking about horizontal, okay? How far it's going to be on in the X direction, okay? All right, so let's find the period for this first function. Notice that this is what I was talking about. This is not fully in graphing form. That's okay for us because we don't need to graph the whole function. They just want the period. And the period is the period of the parent function, which for sine and cosine is 2 pi divided by our b value. We don't need it fully in graphing form to see our b value. Our b value is always the coefficient on our variable. So here the coefficient is 3. So our period is going to be 2 pi over 3, okay? So we don't have to get it in graphing form here because they're only asking about the period. If they did want it in graphing form, just for those of you that are curious, we're not going to make you do this, okay? But for those of you that are curious about it, I would have to factor that 3 out. So graphing form for this would look like y equals 8 cosine 3 theta plus. Now, to factor it out means to divide it out. So pi over 2 divided by 3. When we divide by a fraction, we usually do it by a fraction, so we multiply by the reciprocal. So that would be the same as multiplying by 1/3, and that would become pi over 6. Okay, and that would be graphing form. Before you factor out that b value, the problem is that you don't accurately see your phase shift. This is not your phase shift here until you factor it out that 3. Then this is your phase shift. By the way, you can check your factoring by redistributing. If I multiply 3 times pi over 6, that's 3 over 1 times pi over 6. The 3 on top goes into the 6 on bottom 2 times, and I get back to my original equation, which had pi over 2. Okay, so That's how we would do it if we needed to do it. Those are just algebra skills. So I think you guys could do it if I made you do it, but you're probably feeling relieved that we're not going to make you do that. Okay. So a lot of things are harder during distance learning. And so we're trying to keep this kind of straightforward so that you get the basics this unit. Okay. But I did want you to see that so that you would know that that's what you would do if you wanted to get it in graphing form. Questions for me about that for anybody that's just wondering. Okay. So our period is 2 pi over 3. Will that cause a horizontal stretch or compression? So it normally takes 2 pi units to get through a full cycle. Now it's going to finish in 2 pi over 3. So not even a whole pi, because a whole pi would be 3 pi over 3. It's going to finish in 2 pi over 3 units. Is that a horizontal stretch or compression? And I'll take thoughts from anybody here. Is that going to be a horizontal stretch or compression? Yes, it's a compression, okay? So it is. It's a horizontal compression. Good job, Omar. Okay, it's a horizontal compression. By a factor of what? It's a horizontal compression by a factor of what? Okay, for me, this is where we have to do a little deep thoughts here, okay? A little deep thoughts. Good guess, but not quite, Omar, okay? But I love that you're thinking and willing to put yourself out there. Okay, so let's go back and look at the B value, right? That's what drove the period. That's what drove how fast it finished. This is moving 3 times as fast. This is moving 3 times as fast. So that's going to compress it by a factor of 1/3, by a factor of 1/3. The compression factor for horizontal is always 1 over your B value. It's the reciprocal of your B value. So this is going 3 times as fast, so it's going to finish in 1/3 of the amount of time. Does that make sense? If it's going 3 times as fast, it'll finish in 1/3 of the time. So it'll be a compression of by a factor of 1/3. Okay? Are we okay on that part? Because we're going to do a little mind bending as we answer the next part about frequency. Okay? All right. Okay, so what will the frequency be? Remember, frequency tells us how many units, how many cycles we complete in a given unit of time. The frequency is always 1 over the period. It's always 1 over the period. Okay, so the horizontal compression was 1 over the B value. The frequency is 1 over the period. Be careful and don't confuse those two, okay? So if I go grab my period of 2 pi over 3, and I do the reciprocal of it, 1 over, it just does the reciprocal. If you want to write it as 1 over 2 pi over 3, you can. But then to divide by a fraction, you're going to multiply by the reciprocal. And because you're multiplying by 1, it'll just end up being 3 over 2 pi, okay? So when you see 1 over something, that just means it wants the reciprocal. It just wants you to flip the fraction, okay? So my frequency is 3 over 2 pi. So what does that mean? I think it's helpful to put units with that so that makes sense. That means it's completing 3 cycles every 2 pi units. It's completing 3 cycles every 2 pi units, which should make sense to you because normally it takes 2 pi units to do 1 cycle, but this one is moving 3 times as fast, so it'll finish 3 cycles in 2 pi units. Does that make sense?
Miss Weaver,
Uh-huh.
I'm confused on why it's a horizontal compression because I thought you said if the value's over 1, then it would be a stretch.
That was for vertical. That was for vertical. Remember we said vertical is, we thought about our IHOT over acronyms? And for vertical stretches are exactly what they look like. So when the vertical number, the amplitude out front is a number bigger than 1, it's getting bigger. When it's a number smaller than 1, it's getting smaller, okay? For us, for horizontal is the opposite of what it looks like. Horizontal is the opposite of what it looks like. As far as stretching compressions and most things. Blah, that's ugly.
How do you know which one's horizontal and which one's vertical?
Okay, so the acronym for IHOT over will help you there too. Vertical is outside. Remember, O stands for outside, meaning away from the X is the vertical. It's in that exact direction, and it affects the range or the y values. Okay, the I for IHOD stands for inside, meaning it's with the variable. It's inside with the variable. It affects the horizontal. It's the opposite of what it looks like. And it affects the domain, which is the x values. Okay, so notice that 3, the coefficient on the variable, is inside with the variable. It's going 3 times as fast, so it's going to finish in 1/3 of the time, and that's why it's a compression. Okay, so for me, that's the way I think of it. That's what helps me keep it straight. It's going 3 times as fast, so it'll finish in 1/3 of the time. Okay, so it compresses it and gets it done in just 1/3 of the time. Okay, so 1 over the B value is your horizontal compression. Okay, and it's kind of the opposite of what it looks like. It looks like 3, but it'll be 1/3. And the reasoning there is that it's moving 3 times as fast, so it'll finish in 1/3 of the time. Okay. Now for the frequency, it is going 3 times as fast, so it'll complete 3 cycles in 2 pi units. Questions about that? Did that help?
Yeah, that helps a little bit.
I know it's mind bending. It takes a little repetition and a little time. So that's why we're going to go through a couple. So don't feel, stressed or weird if you don't have your mind wrapped around it yet. Totally takes time. We want you to come back and look at the completed notes and think about it. And I appreciate you asking those good questions. Okay. You can focus on memorizing how to find it, and it'll always work that way. So for horizontal compressions, it's always 1 over B. The frequency is always 1 over the period. Okay, and that will always be true, but it's nice to spend some time trying to understand why. Okay, and so that's why we kind of talk about why it works that way. Okay, but we won't ever ask you for the why. Okay, so let's try another one. Let's try another one of these. This again is not in graphing form because the B value is not factored out. Okay, but can we tell what the B value would be? Okay, I'll take volunteers from anybody on this one. This one's a little harder to spot. What do you see with your algebra eyes? Can you see what the B value is? What coefficient is x being multiplied by? And if nobody can see it, that's fine. I'll show you guys. But anybody think they can see it? What is x being multiplied by there to get x over 5? Okay, I'll kind of walk us through this for a sec. Okay, so x over 5 could be rewritten as 1 over 5 times x over 1, right? We do numerator times numerator and denominator times denominator. So that would be x over 5. Do you guys agree? Everybody with me so far? Okay, so if our denominator is 1, we don't have to write it. So we could write that as just 1/5 x. Notice when I write it that way, the 1/5 is just the coefficient on the x. The x is not under the denominator with the x. It's separate from it. The 1/5 is just the coefficient. Valerie got it and spotted it. That's exactly right, Valerie. The coefficient is 1/5. Okay, so like if you'll imagine the coefficient on that x written as a 1, and then if you look at that fraction, it's that 1 over 5. That's that coefficient on my x. That's my B value. Okay, so my B value here is 1/5. So they want us to find our period. So our period is going to be the period of the parent function, which for sine and cosine is 2 pi, divided by our B value, divided by 1/5. How do we divide by a fraction? We multiply by its reciprocal. So I'm going to multiply by 5 over 1. I mark that out to show we've taken care of it. Then it's numerator times numerator and denominator times denominator. 2 pi times 5 is 10 pi divided by 1. If my denominator is 1, I don't have to write it. So my period this time is 10 pi. My period is 10 pi. Okay, so I have a question for you guys. That coefficient on the x was 1/5. Okay, this means it's moving at 1/5 of the speed. It's moving at 1/5 of the normal speed. So it's moving slower than normal. So will that result in a compression or a stretch? If it's moving at 1/5 of the speed, it's going to take it 5 times as long to finish the cycle. That's going to stretch our graph out to 5 times as long as normal. That's going to be a horizontal stretch. By a factor of We said it's always 1 over b for the horizontal stretch. So 1 over 1/5, which just means the reciprocal or the flip of the fraction. Okay, so 1 over 1/5. Okay, so we multiply by that reciprocal if you want to show the work, or if you just recognize that 1 over just means the reciprocal or the flip of the fraction, you can just do that. 5 over 1 is just 5, so it's by a factor of 5. Okay, it's a horizontal stretch by a factor of 5. This one was a horizontal compression by a factor of 1/3. When it was going 3 times as fast, it finished in 1/3 of the time. It's going 1/5 of the normal speed, so it finishes in 5 times the amount of time as normal. Okay? What will our frequency be? Frequency is always 1 over the period, or the reciprocal of the period. So our period was 10 pi. So our frequency is 1 over 10 pi. What does that mean in words? It means it finishes 1 cycle in every 10 pi units. Okay, and that's what the period said, that it takes it 10 pi units to finish a cycle. So it finishes 1 cycle in 10 pi units. Questions for me about that? Okay, it's mind-stretching math. We are working over here. We are working. Okay, we got 8 minutes left, so I want to jump to the last kind of problem that we're going to do today, which is picking a graph from the equation. Okay, so sometimes they give us the equation and we have to choose the graph that matches. Okay, we're still going to use MAPI to walk us through this. Okay, so I'm still going to write MAPI out to the side. By the way, there was another slide of practice problems in there. So if you want to do more of that horizontal stretch and compression with the frequency, in the blank practice slides in the Schoology folder, you can go find another set that we haven't tried yet. And in the answer key, I have my work shown to find the answer so you can see if you get it right. Okay, so you can do some extra practice on that and check yourself with my answer key in the Schoology folder if you want extra practice with that. Okay, so the first thing I'm looking at, I just want to go through and I want to identify the different parts so we can eliminate some answer choices. So help us get started here. Ananya, what's our midline for this equation? What's our midline? And this one is in graphing form. If you take a look at it, it is in graphing form. So where should our midline be, Ananya? Did we lose her? We're short on time here, so I don't want to wait too long for your responses. Looks like it just popped up there. Taryn's helping us. You're right. The midline's at 3. So if I go look, is 3 the middle of my graph? It is for that one. It is for that one. It is for that one. And it is for that one. Okay, that didn't help us eliminate any answer choices. Okay, what's my amplitude? And I'll take it from anybody here. So just kind of go through this. Okay, Taryn's got us at 2. And notice he said positive 2, even though it looks negative. The negative just tells us it's going to reflect across the axis. So I'm going to put a flower around that so I don't forget it. Okay, this will be a negative cosine graph when we find it. Amplitude is 2, so from 3 we should go up 2 to 5 and down 2 to 1. So up 2 to 5 and down 2 to 1, up 2 to 5, down 2 to 1, up 2 to 5 and down 2 to 1. Okay, they all have the right maximum and minimum, so that didn't let us eliminate any either. Okay, what about my phase shift? What's my phase shift here? Anybody? What's the phase shift? It's my C value. It's 0. That's right, Shay. There is 0 phase shift because nothing is subtracted from the x, so it's 0, which means at 0, I should be starting a negative cosine function. Okay, so what am I looking for at 0? At an x value of 0, where would a negative cosine function start? Negative cosine should start at where? The maximum, midline, or minimum. Where would a negative cosine start? Minimum, okay? So let's go to 0 and make sure we're at a minimum. We are not here, so it's not that graph. Finally, we can eliminate one. Okay, we're at a minimum here. We're at a minimum here. We're at a minimum here. So we only got to eliminate one, but that helped us, okay? At our phase shift or starting point, we should be at a minimum for a negative cosine equation. Now, what about our period? Period is period of the parent function divided by b. My b value here is 1/3. When I divide by 1/3, that's the same as multiplying by 3 over 1. And that's going to give me a period of 6 pi. So it should take 6 pi units to finish a cycle. So on this graph, I started at 0 and I finished at way before 6 pi. 6 pi is way out here. So it's not this one because that's finishing too fast. Okay. This one I started at 0. And when did I finish the cycle? Not at 6 pi. 6 pi is way out here. This was way too fast on my period. Okay. This one starts at 0 and it finishes its cycle right here at 6 pi. Ding, ding, ding. I think we have a winner. You can double check your interval to be sure. 6 pi divided by 4 simplifies down to 3 pi over 2. And sure enough, on that teeny screen that you can't see, that is 3 pi over 2 that it's counting by there. Okay, so that's our correct graph. Questions about that? I don't think we have time to get through our next graphing one. I do have another graphing one, but you guys asked good questions. If you want to practice another graphing elimination one like that, again, it's in our blank slides. Let me show you that. In our Schoology folder for today, the blank slides have it, and then the answer key has the answer and with the work shown to help you check yourself. Okay, so there's some extra practice there if you want it. I won't see you guys until next Thursday, okay, because of Asynchronous Friday, Asynchronous Monday, and Teacher Workday Tuesday. So you've got a whole week to get your Delta Math done and watch the video that's inside Delta Math and take notes on that. Any questions for me before we leave today? Thanks for hanging in there with me. I know that was super long. We will never do that to you again, where we have to just go notes, notes, notes. So thank you guys. I appreciate it. Good work today. Thanks for participating.